Pruthvi Chaitanya, research scholar from IIT Madras, working under the guidance of Professor Mahesh Kumar.
Make
Today,
it full
for the
screen.
theme,
Chaitanya, please make it full screen.
yes, sir, yes, sir. Thank you. Yeah, regarding theme 8, we are, I am able to present about lab testing and validation. The global objective of the work is to show the dynamic, means the objective of the presentation is to uh, related to project that dynamic energy management system for grid interactive microgrid with hybrid energy storage. So regarding this, the global objective of our setup is we are integrating the microgrid testbed setup that consists of various energy sources like PV, wind, storage system consisting of battery and supercapacitors, and the local loads along with the grid connected loads. And yes, sir. In this process, we are taking care of the power quality issues and working on the objectives like following the IEEE report. And we are validating those results which are delivered in the morning presentation. It's an extension of little extension of that. So those individual like scholar setups I am going to present now. And the future task of this means in this presentation, I would like to demonstrate the laboratory setup that we had of each individual scholars. And in the future, we are going to compile the entire work and the setup will be one integrated micro testbed setup. And the task includes modeling, control, and integration of various renewable sources that are PV and wind energy sources, along with hybrid energy storage system, which comprises of battery and supercapacitors to meet the reliable operations of loads under different operating system conditions. And the energy management schemes to address the required power flow among the renewable sources in microgrid, load, and the utility grid will be addressed. So the overall micro integrated test bed setup will be looking like how is shown in figure 1. This consists of both AC and DC type of renewable energy sources. Means it major consists of DC bus and AC bus. The renewable sources are will be connected at both the DC bus as well as at the AC bus, and the loads will also be connected to both the DC loads and AC loads will be taken care of, and the energy or power exchange between the buses will be taken care with the interlinking converters, and the storage system will be connected to the DC side based on the application. And here we have shown the figure, and the respective here the storage system will be connected with bidirectional converters, and the other ancillary services such as the power quality are addressed through both AC and DC grid connected inverters. So here the individual converters are developed and individual setups are developed, and some of them are to be integrated to make the system in whole look like this. So one of those works are here I'm showing an islanded hybrid microgrid system. Here, this is a Droop control system which we were using. It consists of both AC bus and DC bus. The DC bus is formed through a regulated power supply is used as an emulated PV source. We also have a rooftop solar here. We can switch into that. And for this demonstration purpose, I'm showing that regulated power supply is emulated as a PV source, is connected to the DC bus through a boost converter, and the battery and supercapacitor based energy storage system is connected to the DC bus through bidirectional converter shown here. These are made up of IGBT stacks, and the DC bus, which is common to both the inverters, made up of semicron inverter stacks, are connected in common, and the DC bus is common to both the inverters, and the inverter is forming, these two inverters are forming the local bus or point of common coupling AC bus through a proper LCL. These are the feeders that we have considered with proper resistance and inductance values considering the system in the system. And these are the filter section that we have used. And the loads taken care of, the DC loads are taken here. This is connected to the DC bus, and the AC loads are taken here. These are the inductive loads and these are the resistive loads. Here the loads are both R load and RL type. So these were the shown. And the DSpace 1202 microlab box is used for generating the pulses along with the Xylem system generator. This is a simple system generator tool which can be used along with MATLAB. And this setup is used to generate the Droop characteristics in the inverter side and a DC link voltage regulator at the DC bus side. These two, which were I've discussed in the morning session. And the next work is the synchroinverter setup for seamless connection of DERs to the grid. So here in this work, this setup is being used for study of synchroinverter. Um, Synchroinverter control that for grid connected DG in short, which is a control that emulates the behavior of a synchronous generator. A resistive local load is used in the setup, and the whole configuration was connected to the utility grid through breaker. Here, in short, I can say it's a PV rooftop PV source is taken as a DG source here, and the DR here. Inverter is used as a feeding source, and a circuit breaker is used to connect it to the grid through isolation transformer. And the LC filter section is used here. And after LC filter section, a local load is connected here, that is the resistive load. And then the extension of the isolation transformer is fed to the grid. This is the setup. And here the controller is used. The controller used is DSpace 1104, which feeds the pulses to the inverter and also controls the switching of the breaker between the setup and grid. And the next work is a simple hybrid energy storage system based multifunctional DSTATCOM setup. And here the experimental setup is shown here. This is a simple prototype of this STATCOM. That means in the previous setup we have used it in the grid scale, but here it is a step down version. The output voltage is in the range of 110 volts. So 110 volts line to line, and the setup consists of battery and supercapacitor. Here battery and supercapacitor based DC-DC converter. That means bidirectional converters are used to form the DC bus, and the DC link is used for the DSTATCOM application. Here a HIPOI power quality meter is used for the setup, and Elgar source, that is programmable voltage source, is used to create the sag and cell interruption applications. And Hall effect transducers are used for sensing voltage and currents. And the power quality meter is used to measure the source side voltage and the current PHDs. Electronic AC relay is used for the isolation of grid from the load during the voltage interruption. Here also the DSpace 1202 microlab box is used to generate the necessary pulses. And the next setup is this wind energy system emulator for integrated microgrid setup. So here in this work, this a laboratory scale wind emulator developed for hybrid microgrid application. It is used for testing different algorithms like maximum power point tracking, wind speed estimation. So the wind emulator basically consists of a motor generator set, that is the DC motor coupled with a permanent magnet synchronous generator, and the combination is connected to a diode bridge rectifier. So the Hall effect sensor are used. Here this is a system simulator, that is a torque sensor is used. So those measurements were taken in the whole system. This is the indication in the whole system. And this setup is of rating of 1.5 kilowatt, and so and the different wind velocities are configured and fed through the system. That means a host PC. Here the
Yeah, I lost you for a while, but now it is okay.
all right.
Sorry.
So,
Is there any question for him? Hello? Lucas, I'm audible?
Sir, this is
yeah,
yes, sir,
audible,
you are
audible.
Okay,
Yes, sir,
okay.
it is audible.
I'm sorry.